Hello, welcome to the session. So today we are going to study about the fluids which are in motion position. So in last class we are discussing about the properties of fluid itself. But in last class we discussed the properties of fluid which are in rest position. So now we are going to study the properties of the fluid which are in motion position. So let us discuss some of the properties in today's class. So in today's class, let us discuss about streamline flow. So flow of liquid are classified into two types mainly. So that is streamline flow and second one turbulent flow. So here let us consider an example. So here let us consider the flow of liquid like this, flow of liquid. So let the point A, it is having velocity V1 and point B, it is having velocity V2 and point C these are the points in the flow of liquid of the water particles and they are having velocity A, B, C those are the particles and they are having the velocity V1, V2 and V3. So as we know, flowing liquid are considered as incompressible. So it means the density of flowing liquid is constant. The flow of liquid, it may be, sometimes it may be smooth or it may be irregular. The smooth flow of liquid is known as, so what we are going to call the smooth flow of liquid is known as, what we are going to call is known as streamline flow. So that we are going to call streamline flow. Similarly, so again, flow of liquid are classified into two types, that is streamline flow and a turbulent flow. Suppose the flow of liquid is irregular, means it is not moving in constant flow. So irregular flow of liquid is called, what we are going to call, irregular flow of liquid is called turbulent flow we are going to call. So example, the flow of liquid which is flowing in a dam, that is one of the example for turbulent flow. For streamline flow, so here the calm water in a river, you can quote that example. So mainly flow of liquid are classified into two types, streamline flow and turbulent flow. So when we are going to call streamline flow as we know, so streamline flow means, here let us consider one example, flowing water you can consider. So if we are considering flowing water itself, so here in that the water molecules, it consists of different particles. So A, B and C points are shown there and they are moving with velocity, certain velocity V1, V2 and V3 are the velocities of the particles in the flowing water. So the smooth, mainly flow of liquid are classified into how many types? Two types. So streamline flow and turbulent flow. So for what we are going to call streamline flow means, the smooth flow of liquid is known as the streamline flow. Let us consider the flow of liquid in a river itself. Suppose the water is flowing smoothly, means that we are going to call streamline flow. Their velocity of the particle is same, they are having same velocity, constant velocity. Same thing, if the flow of liquid is irregular, means they are moving in a fast position, so then the velocity is not same at every point. So that flow of liquid, irregular flow of liquid, is known as turbulent flow. So let us see some of the characteristics of streamline flow. So here, according to definition, streamline flow, how we are going to define streamline flow. So how we are going to define this one means, so when the flow of a fluid, when the flow of a fluid is such that the velocity of every particle of the fluid at any point is constant. Then the flow is said to be steady, or you can call that one as streamline flow. Streamline flow. So this is the basic definition of streamline flow. How? Let us, we are going to, in order to explain, we are considering this diagram itself. So here let us consider the flow of fluid in the tube. So as shown in the figure. So let the path followed by the particle of the fluid is represented by a line A, B, C. And let V1, V2 and V3 be the velocities of the particle at A, B and C point respectively. If all the succeeding particles of the fluid moving along A, B, C with the velocity V1, V2 and V3 at point A, B, C, then flow of fluid is known as a steady or streamline flow we are called. The path followed by the particles of the fluid in a streamline flow is called streamline we are going to call. And let us see some of the characteristics of streamline flow. Characteristics of streamline flow. So they may ask, mention the characteristics of streamline flow. As we know, the flow of liquid is, so here in that all the particles, they are moving with same velocity. So the some of the characteristics of the streamline flow are, first one, the tangent at any point on the streamline gives the direction. So it gives the direction of the velocity. It gives the direction of the velocity of the fluid particle at that point. So this is the one of the characteristics of streamline flow. And second one, no two streamline can cross each other if they intersect. Then at the point of intersection, the particle of the fluid will have two directions. Will have two directions of motion. So what are two direction means? This is not possible Why? Because hence two streamline cannot cross with each other. So these are the properties of the streamline flow. So here, streamline flow. So the properties of the streamline flow are, so first one, so what are the properties of the streamline flow are? So first property, a tangent at any point on the streamline gives the direction of velocity of the fluid particle at that position. So second point, no two streamline can cross each other. If they intersect, then at the point of intersection, the particle of fluid will have two direction of motion. So this is not possible. Hence, two streamline cannot cross with each other. So these are some of the characteristics of streamline flow. And next one, we shall discuss about another type of flow of liquid, that is turbulent flow, or another terminology we are coming across, laminar flow. So for what we are going to call laminar flow means, so if the liquid flows, over a horizontal surface, in the form of layers of different velocity, then the flow of liquid is called, what kind of fluid we are calling? Laminar flow. So that we are going to call laminar flow. In laminar flow, the particle of one layer does not enter into the another layer. In general, laminar flow is nothing but streamline flow we are going to call. And same thing, next we shall see what is the meaning of turbulent flow. Turbulent flow. Here, example, in reverse, for turbulent flow in reverse, take the example of canal, where in this speed of water is high. Why? Because, or the boundary surface cause, then flow becomes irregular. Such flow of liquid is called turbulent. Here, velocity of the particle is not constant. It varies from one point to another. Flow of fluid in which velocity of the all particles crossing a given point is not same, the motion of the fluid become irregular or disordered. So this we are going to call turbulent flow. Turbulent flow of fluid is, so how we are going to show that one means, so it is shown by the diagram like this. Here all the particles of water molecules, they are not moving in particular velocity, they are moving in zigzag or random position, means they are not having particular position. So this we are going to call turbulent flow, means velocity of the particle is different at different positions. So here these are some, so mainly The flow of liquid, we are going to call that one as two types, that is streamline flow and turbulent flow. Here laminar, and again we are classifying into different types. So that is laminar flow and turbulent flow. So for what we are going to call laminar flow means if the liquid flows over a horizontal surface, from layer of different velocity, the flow of liquid is called laminar flow, or you can call this one as, you can give another name, that is streamlined flow you can call. So turbulent flow. So turbulent flow means you can put the example of river, or you can put the example of canal. So in river or in canal, the speed of the water is high. Therefore, the water moving with irregular shape, and all the particles, they are not having constant velocity, they are moving with different velocity, therefore it is called as turbulent flow. So here some of the characteristics also we discuss. Characteristics of the streamline flow are: first one, tangent at any point of the streamline gives the direction of velocity of the fluid particle at that point. And second one, no two streamline can cross with each other. If they intersect, then the point of intersection, the particle of the fluid will have two direction of motion. This is not possible, hence two streamline cannot cross with each other. So these are the characteristics of the streamline flow. So next we shall discuss about energies. So that is energy of a liquid. So mainly energy of liquid is classified into three types. So those are, so first one, kinetic energy. Second one, potential energy. Third one, pressure energy. So how we are going to define kinetic energy? So always kinetic energy is given by the formula Ke is equal to half mv square. So here kinetic energy per unit mass, kinetic energy per unit mass is given by the formula half mv square. Per unit mass is there, therefore divided by m. This m get cancelled. So we are having expression for kinetic energy is half v square. Same thing, potential energy is given by the formula Pe is equal to mgh. Same thing, potential energy per unit mass means divided by m. So this m get cancelled. We are having potential energy is given by only gh. And pressure energy per unit mass. Pressure energy per unit mass. Pressure energy per unit mass of liquid is given by the formula P into dB by rho into dB. So this get cancelled, only we are having pressure divided by density. So here mainly flow, let us consider this diagram. So here let us consider like this diagram. So it is filled with water. It is filled with water, and at this end it is fitted with a piston. It is piston, and it is having the area of cross section dx. So here mainly energy of liquid are classified into how many types? Mainly energy of liquid are classified into three types. That is, first one kinetic energy, second one potential energy, and third one pressure energy. So kinetic energy means it is the energy possessed by the liquid by virtue of its position. So, and kinetic energy, it is given by the formula Ke is equal to half mv square. Whereas potential energy is, that is energy possessed by the liquid in a particular position by, or how we are going to define that one, energy possessed by the liquid by virtue of its position. So potential energy is given by the formula mgh. So therefore potential energy per unit mass is given by mgh divided by mass. So get cancelled, so remaining we are having g into h. G is the acceleration due to gravity, h is the height. So pressure energy is nothing but, so pressure energy per unit mass of the liquid is given by P into dV divided by rho into dV. So dV gets cancelled. Only we are having pressure divided by density rho. So let us explain one by one this one. How we are going to explain? Let us see this one. So mainly, so energy of a liquid are classified into how many types? 3 types. So energy of a liquid are classified into 3 types. So liquid can possess 3 types of energy, that is kinetic energy, potential energy, and pressure energy. And the energy possessed by liquid due to its motion is called kinetic energy. This is first one. And second one, and it is represented by half mv square. And per unit volume means we are going to divide by m. Therefore, kinetic energy is given by half into v square, where half is the constant, v is the velocity of the particle. And second one is potential energy. Potential energy is represented by mgh, and potential energy per unit mass is given by mgh divided by mass. Mass get cancelled with each other. Potential energy is given by g into h. G is acceleration due to gravity, h is the height. And pressure energy is nothing but, third type is pressure energy. And pressure energy means energy possessed by a liquid by virtue of its pressure is called pressure energy. And how this pressure energy it comes, let us see. So we are going to derive the expression for pressure energy. So pressure energy, how it comes, let us see. So let us consider this diagram itself in order to explain this pressure energy. So here, consider the vessel, it is fitted with piston here. So at one end side, so let this vessel is filled with water of density rho, and A be the area of cross section of the piston, and P is the pressure experienced by the liquid. Therefore, so imagine that diagram. So force acting on piston is given by the formula P into A. P is the pressure, A is the area of cross section. If dx be the distance moved by the piston, then if dx is the distance, so that is moved by the piston, therefore then work done by the force is given by the formula P into A into dx, that is nothing but P into dV, where dV is nothing but A area into dx. So volume of the liquid swept. This work done is equal to the pressure energy of the liquid. Therefore, pressure energy of liquid in volume dV is given by P into dV. The mass of the liquid having volume dV is, that is equal to rho into dV, where rho is the density of liquid, that is density of liquid. Therefore, pressure energy per unit mass of liquid is given by the formula P into dV divided by rho into dV. So dV gets cancelled. We are having P divided by rho. This is the expression for energy, that is pressure energy. And you have to remember this one. And next, we shall see next concept, that is Bernoulli's theorem. So let us discuss about next concept, that is Bernoulli's principle. So what is the statement of Bernoulli's principle means? So statement what it states is, so along the streamline, of an ideal fluid, the sum of potential energy, kinetic energy, and pressure energy per unit mass remains constant. So this is the statement of Bernoulli's principle. So in order to explain this one, so here we are considering this diagram. So we are considering the tube. So here this is, let us consider this is point A in the tube for flow of liquid, and this is point B. So P1 and P2 are the pressure, and this is at height, certain height H1, and this height is H2, and V1 and V2 are the velocity of flow of liquid at point A and B, So let us explain this diagram. In order to explain Bernoulli's theorem, so we are drawing this diagram. Here the water is flowing in this tube. So Bernoulli's principle, what it states, let us see. So here it explains Bernoulli's principle. What it states is, along the streamline of an ideal liquid, the sum of potential energy, kinetic energy, and pressure energy per unit mass remains constant. So let us explain how it remains constant. Let us derive an expression. So in order to derive, or in order to show the Bernoulli's principle, so that is along the streamlined flow, the ideal fluid, in that sum of potential energy, kinetic energy, and pressure energy per unit mass remains constant. In order to explain that one, so we are going to derive one derivation. So let us consider this tube. In this tube, A and B are the two positions in the flow of liquid. V1 and V2 are the velocities of flow of liquid. P1 is the pressure at point A, and P2 is the pressure at point B. H is the height of the position of the point A, and H2 is the, that is height of the position of point B. So let us derive this equation. Let us prove this Bernoulli's principle. So how it is, let us see. So first, consider the liquid to be flowing. So let us consider this diagram itself in order to explain Bernoulli's principle. So consider a liquid to be flowing inside a tube in a streamlined motion. Let P1, A1, B1, H1 be the pressure, area of cross section, velocity, and height of the liquid at point A here. And same thing, P2, A2, P2, A2, V2, and H2 be the area of cross section, and velocity and height at point B respectively. So here P1, V1, A1, and H1. So here these are the points. Then change in gravitational potential energy. So therefore change in gravitational potential change in gravitational potential energy is given by, how we are going to represent, it is given by U2 minus of U1 is equal to delta V rho G H2 minus of delta V rho G H1 at point A and B. Same thing, delta U2 minus of U1 is nothing but change in gravitational potential energy. So that is represented by delta V rho G is common, H2 minus of H1. So next, if this is all about, that is gravitational potential energy. If the density of fluid, if the density of fluid is rho, then mass passing through the pipe, it is passing through the pipe in a time delta T is given by, the formula is given by, so that is given by mass delta M is equal to rho A1 V1 into delta T, that is nothing but P. So this is P into, so this whole thing we are substituting into delta V rho A1 V1 into delta T, that whole thing is substituted as delta V. Therefore, in the next step, change in kinetic energy is given by delta K is equal to half into delta V, that is rho into V2 square minus of V1 square. So next, by applying work energy theorem, so we are writing this one, P1 minus of P2 into delta V is equal to half rho delta V in the bracket V2 square minus of V1 square plus of rho G delta V in the bracket H2 minus of H1. So each term by delta V. So then we are getting, if we divide this whole thing by delta V, it becomes P1 minus of P2. That's equal to half rho V2 square minus of V1 square plus of rho G H2 minus of H1. And rearranging above equation. So to get Bernoulli's equation, then it becomes P1 plus of half rho V1 square plus of rho G H1 is equal to P2 plus of half rho V2 square plus of rho G H2. So since 1 and 2 means the point 1 and 2 refers to point along pipeline, therefore it is given by P rho GH is equal to constant. So this is the final expression for Bernoulli's principle. So how we are going to represent that one means, so this how we are going to explain that Bernoulli's principle means. So here how we are going to represent that one means, Bernoulli's principle, what it states, along the streamlined flow of an ideal liquid, sum of potential energy, kinetic energy and pressure energy per unit mass remains constant. We already know that one. And here this is the diagram used to explain Bernoulli's principle. And next, So here we have to explain that one. We are having 2 points. So in that pipe, change in gravitational potential energy is given by U2 minus of U1 is equal to delta V rho G H2 minus of delta V rho G H1 it is. And the same thing, difference of 2 points we are getting, delta U is equal to delta V rho G H is common term, and difference of H2 minus of H1 is written as it is. And if the density of the fluid is rho, the mass passing through the pipe in time t is given by delta m is equal to rho A1 V1 into delta t is equal to P into delta V. Therefore, change in kinetic energy is given by delta K is equal to half delta V rho in the bracket V2 minus of V1. So difference of 2 points we are taking. And next, change in gravitational potential is over. And next, kinetic energy is also over. By applying work energy theorem, so P1 minus of P2 into delta V is equal to half rho delta V. We are taking common V2 minus V2 square minus of V1 square plus of rho G delta V in the bracket H2 minus of H1. So divide whole thing by delta V. So if we divide that one, what we are getting? So if we divide that one, so delta V, so this equation is divided by delta V means, so delta V, delta V, delta V, delta V, so gets cancelled with each other. So after cancelling everything, remaining we are what we are getting, P1 minus of P2 is equal to half rho V2 square in the half rho in the bracket V2 square minus of P1 square plus rho G in the bracket H2 minus of H1. So rearranging the terms, what we are getting, P1 plus, so P1 term is taking in the left hand side and P2 term is taking in the right hand side. So then we are getting, so P1 plus of half rho V1 square plus rho G H1 is written in the left hand side. That's equal to P2 plus of half rho V2 square plus of rho G H2. So on at the point 192 are the 2 points on the pipe along the line. So the difference of 2 minus of P1, we are writing that one as P, and half rho V2 minus of P1, we are writing that is V. V is the velocity of the particle, plus of rho J H2 minus H1 is height. So therefore, Bernoulli's principle, according to Bernoulli's principle, the sum of potential energy, kinetic energy, and gravitational potential energy remains constant. So P plus of half rho V1 square plus of rho G H is equal to constant. This is the derivation of Bernoulli's principle. I hope you got this one. Try to practice this one. So in today's class, what and all we discussed is, so we discussed different types of fluid. So flow of liquid mainly classified into 2 types, that is streamline flow and turbulent flow. Streamline flow means the smooth flow of liquid is known as streamline flow. Irregular flow of liquid is known as turbulent flow. And here again, some of the characteristics of the streamline flow we discussed. And laminar flow. Laminar flow means the flow of liquid flows over a horizontal surface. So from the layers of different velocities, the flow of liquid is called laminar flow. Turbulent flow means irregular flow of liquid. Already that is shown in this diagram. So same thing, and we discussed about energy of liquid are classified into 3 types: kinetic energy, potential energy, and gravitational potential energy. And already shown, kinetic energy is given by half V square, potential energy is given by G into H, and pressure energy per unit mass of the liquid is given by P divided by rho. And same thing, Bernoulli's pressure energy, how that expression we derived, I already showed this one. And we discussed about Bernoulli's principle, that is along the streamlined flow, the sum of potential energy, kinetic energy, and pressure energy remains constant. And we derived the expression for Bernoulli's principle. So here, this is the derivation. I hope you got this one. So if you want to note down, you can note down in between. So if you are having any doubt, you can ask. If no doubt means